All right, so we're coming back to our graphs of exponential functions. In the previous video, we had done graphs with base greater than 1. Now we're going to look at graphs that are between 0 and 1. And so our first one, e to the negative x. And remember when we looked at exponential functions, right? If it was between 0 and 1, we would have a decay or depreciation and it would be going down. And if we look at that on our graphing calculators, 1 over e to the negative x. And remember, a negative means to take the reciprocal, the negative in the exponent. So this would be the same as saying 1 divided by, oops, not 10, but e to the x. And you see if we graph both of those, they will look exactly the same. So here we are, see, we're going down, we're getting closer to 0. And you don't even see the second graph because it's the exact same graph. And so how do we know that this e to the negative x is actually a base between 0 and 1? Well, if I go back to our home screen and I did 1 divided by e raised to the first, notice that we get 0.367, right? That's a number between 0 and 1. Okay, so going back to our graph, right, we know that our domain is all real numbers. Range is y is greater than 0. For our x-intercept, there is none. For the y-intercept, it's still 0, 1. And we have a horizontal asymptote at y equals 0. Okay, so now we go over here, we have negative x plus 2. And right, the initial instinct to think, well, that goes 2 units to the left. But one of the things to remember is that we have to factor out that negative 1. And so really what we have is negative 1x minus 2. So it's really a shift 2 units to the right. So here we'll go to our y equals. I'll get rid of that second one because we don't need that. And so now we're going to do e raised. And I'll just leave it as negative x plus 2. And here comes our first graph. And then watch, you'll see the second one will be shifted 2 units to the right, right? Because that's an x minus 2, that shifts it 2 units to the right. With just the horizontal shift, that doesn't change any of our graphs in terms of domain range. It would change the y-intercept. And if we substitute 0, we get negative 1 times negative 2, which is 2. So the y-intercept would be 0 and then e squared, right? And notice that if I do second calc, the value is 0. For the first graph, set 1. For the next graph, that number is e squared. Okay, so moving on to problem number 3. So again, we have a negative x minus 3. We're going to factor out that negative 1 again. And we end up with x plus 3. So this one will be a shift 3 to the left. So we're going to go back to y equals. And so I'm going to do negative x minus 3. And you'll see here comes the graph of our original one. And there it is. You can see that it is shifted 3 to the left. And if we plug in 0 for our x to get the y-intercept, you'd have 1, 0 for x, and for our y value, you get e to the negative 3 or 1 over e cubed. Okay, so here now we've got a few transformations, and we've changed our base, still a number between 0 and 1. So I'm going to clear out those, and I'll put in 0.5 raised to the x as our parent graph. And again, notice it looks just like 1 over e to the x. Very similar. And so now we're going to do 3 times, and I'm going to do this in parentheses, 0.5 raised, and in parentheses I'm going to do x plus 2 and then minus 3. So the 3 in the front, excuse me, is going to be a vertical stretch. the x plus 2 is going to move the graph 2 units to the left, and then the minus 3 is going to move it 3 down. So hopefully you can see there that we've gone 2 to the left, 3 down, and we are a little bit steeper. So there are some things that this has changed, right? I'll work my way back up. Our horizontal asymptote will now be at y equals -3. Domain still all real numbers. Range now is y is greater than -3. For our x-intercept, okay, we do have one. We can find it on our calculators, but probably we're going to need to, because we haven't really learned how to do this yet. So second calc 0, I'm going to jump down to the second curve. We're going to move the left, the cursor to have a left bound, and then a right bound, and we see it's at x equals -2. Again, we'll learn how to solve those kinds of equations soon. And then our y-intercept, if we plug in 0 for x, we get 1/2 squared, which is 1/4. We get 3/4 when we multiply that by 3. Minus 3 is -2 and 1/4. Okay. One of the things that we didn't do in the last video is we didn't reflect it about the x-axis, and that's what our negative is going to do when it's in front, -1 times that. So we're going to go back to our y equals. And I'm going to put in e to the x, and then we'll see the negative of e to the x. And then here comes our e to the x. That'll be the first one. Oh, I didn't do -x, so there's my, let's see. Yep, my apologies. I didn't do -x in there, which we meant to be doing, right? So there's our e to the -x. And I didn't do negative there either, so let's put in a -x because we are working with bases between 0 and 1 in this video. Okay, so here's our e to the -x, and then notice the negative just flips it over. So in terms of our domain is still all real numbers. The range now is y is less than 0 instead of greater than 0. We do not have an x-intercept. For the y-intercept, instead of 0, 1, it's 0, -1. And for our horizontal asymptote, it's still at y equals 0. All right, so again, we've added a few transformations here, a little bit steeper, flipped over the x-axis, moved 2 to the right, and up 4. So let's go back. And I'm going to take that one out because we are really comparing it to that one more. So we have -2 and then e raised to, I didn't put the -x in. So let's leave it as -x minus 2 plus 4. So that's actually going to go now 2 to the left instead of 2 to the right. So there's actually the first graph you can see flipped over, 2 to the left and 4 up. So a lot going on there. So our domain is still all real numbers. So the range, right, we can see 1, 2, 3, we're not getting to 4, so y is less than 4. For the x-intercept, we're going to have to use our calculators because, again, we don't know how to do that quite yet. We'll get to that soon in this unit. So I'm going to move the cursor. We're going to do a left bound, and then we'll do a right bound and an enter, and we get -2.693. For the y-intercept, I can do that real fast here. Value, plug in 0, and we get 3.729. And then for a horizontal asymptote, that would be at y equals 4. So lots going on there with our graphs of exponential functions with the base between 0 and 1. Hope that helps, and we'll see you soon.